Swayam Prabha. Digital India. Educated India.
Now we are going to solve a numerical example related to a full CPNN. Now, if you see the network which I have already discussed, actually here, so this is the schematic view of this full CPNN, and let me give you the statement of this particular problem first. For this CPNN, actually we are going to pass through 3 inputs, and that is your x1, x2 and x3. Now, x1, x2 and x3 are nothing but 0.3, 0.5 and 0.6, and its corresponding outputs are 0.3 and 0.4. And let us consider that there are only 2 neurons in the hidden layer. So, we are considering 2 neurons in the hidden layer here, and these x1, x2 and x3 are the inputs, and these are nothing but the outputs. And here we consider there are 2 such input layer, one is this, another is this, and the connecting weights u, v, w, s, the way I discussed, and these are all star condition for the x and star condition for the y. Now, let us see the connecting weights between so this particular the neuron. Let me just put some number here, then it will be easy. So, let me consider say 1 here, 2 here, 3 here. So, this is nothing but u11. So, this connecting weight is nothing but u11, then this is nothing but u21, then comes your, so this is nothing but u22 and so on. Now, similarly, here if I just put 1 and 2, so the connecting weights between this and this, so this is nothing but is your V11, then comes your V12 and so on. Now, similarly, we have got the connecting weights, the W and S here. Now, these numerical values of the connecting weights are assumed to be as follows. Now, here we have written all the initial connecting weights, like u11 is 0.2, u12 is 0.3 and so on. So, this is the way actually we can write down this the numerical values for the connecting weights. Then V is nothing but this, then comes your S is nothing but this, and the W, the connecting weight matrix, is nothing but this. Now, if this is the situation, now this shows actually the connecting weights, and we can assume the learning rate values are as follows. For example, say alpha is nothing but this, then comes beta is 0.3, gamma is 0.1, delta is 0.4, and our aim is to calculate like x1 star, x2 star, x3 star, then y1 star and y2 star at the end of first iteration. Now, here we are going to show only one iteration, and let us see how does it work. Now, this is another view of this in-star model, and these are nothing but the x inputs, these are the y inputs. So, x1 is 0.3, x2 is 0.5, x3 is 0.6 and y1 is 0.3 and y2 is nothing but 0.4. And if you see the connecting weights, so this particular connecting weights is 0.2, 0.3 and so on, and here also we have got the connecting weights. Now, the first thing which you will have to do is you will have to find out the Euclidean distance from these 2 hidden neurons, and we will have to declare a winner out of these 2. Now, let us see how to proceed that particular the calculation. That means, we are going to concentrate on the in-star model, Now, here in this instar model, so our aim is to find out this particular the distance value. Now, this d1 is nothing but square root of summation I equals to 1 to 3 x I minus u I 1 square plus summation k equals to 1 to 2 y k minus v k 1 square. Now, here you can see that I varies from 1 to 3, that means I put x 1 minus u 1 1 square plus x 2 minus u 2 1 square plus x 3 minus u 3 1 square. So, this is the thing. Next we put k equals to 1 to 2. So, I put k equals to 1. So, y 1 minus v 1 1 is nothing but this, then k equals to 2. So, y 2 minus v 2 1 is nothing but this and square, and if we calculate, so I will be getting this particular d 1 as 0.51. Now, on the hidden layer, in fact, we have got 2 such neuron. So, I will have to calculate in fact another d value. Now, that is your d 2. Now, this particular d 2 is nothing but square root summation I equals to 1 to 3 x I minus u I 2 square plus summation k equals to 1 to 2 y k minus v k 2 square. Now, I put I equals to 1, I will be getting x 1 minus u 1 2 square plus x 2 minus u 2 2 square plus x 3 minus u 3 2 square plus summation k equals to 1 to 2. So, this is nothing but y k minus v k 2 square, k equals to 1. So, y 1 minus v 1 2 square plus y 2 minus v 2 2 square, and if you calculate you will be getting, so d 2 is equals to 0.44. Now, if you remember d 1 was your 0.51, and if I compare, so this particular d 1 and d 2, so d 2 is found to be less compared to d 1. So, Z 2 is actually the winner. So, through this competition Z 2 has been declared as winner. Now, once we have got this particular winner, now we are in a position to update the connecting weights. For example, say u 1 to updated is nothing but u 1 to previous plus alpha x 1 minus u 1 to previous. Now, we substitute the numerical values and we can find out that this particular u 1 to updated will be 0.3. That means, there is no change in this particular the u 1 to value. Now, here if you just go for the updating of the other parameters, like your u 2 to updated is nothing but u 2 to previous plus alpha into x 2 minus u 2 to previous. Now, if you substitute the numerical values and calculate, so u 2 to updated will be your 0.58. Then comes here u 3 to updated is nothing but u 3 to previous plus alpha into x 3 minus u 3 to previous, and if you substitute the numerical values you will be getting 0.52. Similarly, we can find out the updated values for your v, that is v 1 to updated is nothing but v 1 to previous plus beta multiplied by y 1 minus v 1 to previous. Once again, if I substitute the numerical values, so I will be getting say 0.58. The next we will have to update this v 2 to. So, v 2 to updated is nothing but v 2 to previous plus beta into y 2 minus v 2 to previous, and if you submit the numerical values, then you will be getting that v 2 to updated is nothing but 0.33. Now, this is the way actually we can find out the updated value, and once you have got that, now we are in a position to carry out the outstar model. Now, here in the outstar model, so we will have to consider the winner hidden neuron, and that is nothing but your Z2. And if you see, so this is one set of connecting weights, another set of connecting weights, and those connecting weights once again we will have to update. Now, if you update those connecting weights, like your W21 updated is nothing but W21 previous plus gamma multiplied by x1 minus W21 previous, and if you substitute the numerical values and calculate, so W21 updated will be 0.21. Similarly, W22 updated is nothing but W22 previous plus gamma multiplied by x2 minus W22 previous, and if you substitute the numerical values you will be getting 0.32. Then W23 updated is nothing but W23 previous plus gamma into x3 minus W23 previous, and if you substitute the numerical values you will be getting 0.42. Then ACE21 updated is nothing but ACE21 previous plus delta into y1 minus ACE21 previous, and if you substitute the numerical values you will be getting 0.42. Now, the same procedure we will have to use for updating ACE22. Now, ACE22 updated is nothing but ACE22 previous plus delta into y2 minus ACE22 previous, and if you substitute the numerical values you will be getting that is equals to 0.58. Now, what you do is those updated values we are going to assign here. So, if you see x1 star is nothing but 0.21, if you see the previous the updated value for this thing. So, this is your 0.21. So, x1 star is nothing but 0.21, x2 star is 0.32 and x3 star 0.42, y1 star is 0.42 and y2 star is 0.58. Now, this is the way actually we can complete one iteration of these particular the CPNN. Now, so we will have to repeat, and then through a number of iterations we will be getting that particular the relationship. Now, till now we have discussed the working principle of multi-layered feed forward network, and that is very popularly known as the back propagation neural network. We have also discussed the principle of radial basis function network. Then comes we discussed a recurrent neural network, and after that we concentrated on the self organizing map which works on unsupervised learning, and then we concentrated on the counter propagation neural network, that is CPNN, which actually uses the concept of both supervised as well as your unsupervised learning. And the main purpose of developing these particular networks is to establish the input output relationship. So, the problems related to data mining we can solve using the different types of the neural networks. Now, for the your further study you can concentrate on the textbook of this particular course, that is soft computing fundamentals and applications. So, you can see this particular the textbook for more details, and so let us summarize, like which we have already discussed little bit, like we have discussed the principle of multi-layered feed forward network, radial basis function network, then comes your recurrent network. So, these three networks works based on the supervised learning, and then we concentrated on the self organizing map. It is a very efficient tool for dimensionality reduction or visualization. It is also an efficient tool for clustering, and using the concept of self organizing map we have discussed how to design and develop this counter propagation neural network, and once again the purpose is to model the input output relationship. Now, here we have discussed different types of networks, and let me repeat once again the purpose of actually designing different types of networks is once again how to model the human brain in the artificial way. Now, we have already discussed the principle of fuzzy logic, we have already discussed the principle of neural networks, and we have seen like how to evolve the fuzzy reasoning tool, fuzzy clustering tool and all such things. And in the next lecture, in fact, we are going to see how to evolve a particular the network and what is the basic principle based on which we can evolve very efficient network, so that we can do this type of input output modeling in a very efficient way. Thank you.